Okay, today we're going to see this example that you see on the screen is a hydraulic system, and you have the hydraulic system in here that has consider this input here and the inertia effect and also some friction effect on the side. Is considering also the compressibility of the fluid, that's why we have the C element over here. And on the other side we have this inertia effect and some friction effect also. So the objective of our example today is to obtain the state space form, first of all by hand, and second using CAMP-G. So let's do it. Okay. So the first thing that I would like to do is to complete the causal marks so that we can actually get the equations correctly. So this would be, we put the SC in this way, this one in integral form makes this 2 to be like this. Once that happens, this is like this. And then of course in here, in integral form, the C element, that makes this one like this. The I also in integral form completes the causal assignment. So in here, we recognize we have 1 and we have 2 and we have 3 differential equations that we need to deal with. So we could start with, in any order, with this, or with this, just following the causal marks and the what we need to, we could derive the equation. Like for example, in this case, I would say that we could start with dp sub 8 dt. This is going to be equal to e sub 8, right? But e8 is equal to e sub 7. The way it is in here is e8 is e7. No, I think we have, wait a second. This is a 9, right? Sorry. So it's e sub 9 plus e7 minus e10. So e sub 9 is basically the source SE9 plus e sub 7 in this case is e sub 6, and then minus e10 is going to be f sub 10 times r sub 10. So we continue on with this derivation where you have SE9, but E sub 6 is 1 over C sub 6 Q sub 6 minus what's F10 is F8. Since it's homework is due tonight, can we skip just the computer portion? So Q sub 6, and then this is F sub 10 is, of course, is F sub 8. And we have, this would be F sub 8 times R sub 10. So finally, we can just write the first equation, which would be SE9 minus 1 over C sub 6 Q sub 6 minus 1 over I sub 8 times R sub 10 and then P sub 8. And so this is my first differential equation like this. The second differential equation that we have is this dq sub 6 dt is equal to f sub 6, and f sub 6 is f5 minus f sub 7, and then we have f5 is f4 times this module, which is the ratio of this area A1 and A2 like this. You know, this is the ratio is, why don't we just put M is A1 and A2. But F sub 5 in this case is F sub 4 times M, and F sub 7 is F sub 8. So F4 is going to be F2, and then we got the second differential equation already. The QDT is going to be F2, which would be 1 over I sub 2 P sub 2 times the M in here, minus F sub 8, which would be 1 over I sub 8, and then P sub 8. And that is equation number 2. We have only one more to go. The equation here is, we have the last one that we have is Q P sub 2, right? So d P sub 2 dt is going to be E sub 2. But E sub 2 is equal to E1 minus E3 and minus E sub 4. Okay? So in here, E1 is the SE1, and then you have minus E sub 3, which is F sub 3 times R sub 3, minus E sub 4, which would be E sub 4 is E5 times M. And so we'll continue here. This is going to be SE1 minus F sub 3. In this case, F3 is F2. This is F sub 2 times R sub 3 minus E sub 5. In this case, E sub 5 is E sub 6, which is 1 over, this, well, why don't we just put it here? E sub 6 times M. So SE1 minus F2 is 1 over I sub 2 times R sub 3 times P sub 2. And then minus E5 is what? E5 is 1 over C sub 6 times Q sub 6. So we are done. This is the third equation. dP sub 2 dt is going to be SE1 minus R sub 3 over I sub 2 times P sub 2 minus 1 over C sub 6 times M times Q sub 6. And that's equation number 3. With these equations, we could already produce the A and the B matrix. Now, but you see, our objective is to do the state space form. That state space form calls for a form that says that x dot is equal to the matrix A times the vector of the state variables x plus the matrix B times the vector of inputs. And then they have the output equations, which is, this would be C times the state space vector plus D times U, like this. Yeah? So I think what we need to do is define the outputs, and now we are ready to go. Here, what are the outputs for that we want on the system? I should have that outlined at the very beginning, but since I didn't, I only have to do it now. For example, I could have the velocity of the second mass, which would be f sub 8, for example. B of m2, which would be f sub 8. And I also could find out what is the, for example, the pressure on this side here, the pressure on this, like E2, for example. So P of pressure of M1, which would be E sub 2. So these two are the outputs. So if you write the equation for the output also, F sub 3 in this case, what did I put? Is F, no, F8, I was reading it wrong. F8, what's F8? This is 1 over I sub 8, P sub 8. And what is the other one, this E2? E2 is E1 minus E sub 3 and minus E sub 4. But that one we already did it over here, see? So E2, let me just make sure that we put a line so we don't get confused. But E sub 2 is this. It's actually this equation. So I am going to go ahead and write down that E2 is equal to SE1 minus R sub 3 over I sub 2 P sub 2 minus M over C sub 6 Q sub 6. And with this equation in here, and this one in here, I am ready to generate the matrices. Now, the way you do it is you put it like this. This is d p sub 8 dt, and then you put dq sub 6 dt, and then you have this dp sub 2 dt like this. And then you put the matrix in here, which would be your matrix A. And then you have the vector of the state space in here. Then the matrix B. And then the matrix is SE. What do we have in this case? We have SE1 and SE9, two of them. Okay, so in here we go. This would have the state variables. Like in here you have P sub 8, and then you have Q sub 6, and then you have P sub 2. So what is the idea here? We have this, from this equation, you have minus 1 over I sub 8, and then then you have a 0, and then M over I sub 2, and then you have a, what did I do? No, I am looking at this wrong. This is minus, oof. Sorry, I was looking at the wrong equation. I was looking at the second one instead of the first. We need to look at this one. Okay, SE9, so this has a 1 and has a 0 here. Q sub 6 is, but it has P sub 8, yes it does. Minus R sub 10 over I sub 8 in here. Q sub 6 is minus 1 over C sub 6, and P2 is 0. That's this equation. Second equation, this you have that this is P sub 8 is a minus minus 1 over I sub 8, and then Q sub 6 is 0, and then P sub 2 is M over I sub 2. And then you have this, yeah. So that's the second equation. The third, oh, what about this in here? This is going to be 0, 0 because no inputs in here. Now the other one, SE1, is 1. And then you have P sub Q sub 6, so P sub 8 is 0, and Q sub 6 would be minus M over C sub 6, and then this would be minus R sub 3 over I sub 2. And so this is your answer for this is your matrix A, and this is your matrix B. Okay, what about the C and the D? We need to look at these outputs in here. Like in this case, you're going to write that the first output is F sub 8, and the second output is E sub 2. So in here, you're going to have, again, the matrix. This would be the C matrix multiplied by the state vector. So then multiply by the state vector, which would be P sub 8, would be Q sub 6, and P sub 2. Okay. And then plus the D matrix times the vector of the inputs SE1, SE9. And then how do we do it? The one is on 1 over I sub 8, 1 over I sub 8, and then 0, 0, and then of course 0 here, and 0 there. Okay, and then the second one, E2, is SE1, which is a 1, and then this is a 0, and then this would be P sub Q sub 6, this is minus M over C sub 6, okay, and then minus R sub 3 over I sub 2. This is the end of this exercise by hand. So this is the C matrix, and this is the D matrix. Okay, so this is what we have right now, as we have derived it by hand. This is state space form.